So you start out being born and not knowing anything, right? Um, there are most things that you learn in life, you kind of learn by accident. You learn by testing them out. Learning to ride a bike, you don't just pick it up and immediately know how to use it. You also don't read an instruction manual on how to do it. The only way you really learn how to ride a bike is by trying it and figuring out how to balance, basically, how to, what the edge cases are. If I turn the wheel, or if I turn the handlebars too much, I fall over. If I go too slow, I fall over. If I go too fast, I have a hard time stopping, right? This is learning by testing. So part of getting better at anything is overcoming the fear of breaking things, right? When you take off the training wheels, you have to get over the fear that you are going to crash and fall, right, in order to get better. So in life, there's not really a reset button for a lot of things. There is, if you get in an accident on a bike, you get in physical harm. The nice thing about building apps and writing software is that basically in almost all circumstances, we do have a reset button, right? You can restart the app, you can refresh the page. There is this really nice built-in aspect to it where you can start over. And so therefore, it's okay to fail. It's okay to break stuff. So where you don't want to break stuff is when other people are using your software, right? You want to make sure that it's going to work reliably, and also that any changes you make aren't going to accidentally break some other part that you didn't manually test, right? Who in here works at a place where there's a manual, like QA, like testing kind of procedure? Okay, decent number. I'd say it's less and less common to actually have people clicking through all your forms, signing up, and all these different sort of workflows on your app before you release. So if you don't have those people, and even with manual testing, it's very easy to miss things. Automated testing is really about mitigating risk. It's about protecting you from yourself. So you can restart your app, you can refresh the page, but how do you ensure that any change you make isn't going to break, the login form or whatever? This is what automated testing is about. It's confirming that whatever you have written tests for is going to work no matter what changes you make. All right? So they're there to mitigate risk. So other examples of mitigating risk, version control, right? You could just email files back and forth. You could put them all in a shared Dropbox folder, but that's really leaves a lot of room for error, for screwing up, right? So version control has this really nice property of if you break something, you can just undo it, right? You can go back to a previous state. Abstraction is a way of mitigating risk. So rather than trying to implement click handlers or whatever that work across all browsers, even IE6, that's a really difficult thing to do. Using jQuery or using a library, that abstraction gives you the confidence that, okay, they've figured out the hard parts, or I can work at this level where I don't have to really care about the minutia of what's different in this browser versus another. And testing is the way that we're going to talk about today. So there are a few flavors of testing. Sorry, that's really tiny. So there are a few flavors of testing. One is unit testing, and the other is integration. And everything else is sort of on the spectrum in between. So unit testing is taking some piece of your app and testing it in isolation, right? Does this thing work? If I were testing a bike, does the shifter work? Does the seat not fall down? Does the frame not bend? Whatever it might be. So you're thinking about individual pieces and making sure that those work by themselves. Integration testing is the other end of the spectrum where you say, does this bike not fall apart when I ride it? How do all these pieces work together, and are they all connected properly? So the way I think about it is unit testing is a piece in isolation, but also everything below it. So there are different opinions on this, but for example, if you have a model, so on the front end, on the back end, whatever, something that deals with data, you're not only testing, you could just be testing the logic in the model itself, any instance methods or what have you, but you might also be testing that it's able to save to the database properly, or that it's able to retrieve things properly. If you are testing your routing in your app, you might test that not only does the routing work in that it captures whatever your URL is, but you're able to then see whatever's supposed to appear on the page, right? So the views then sort of sit below the routing. So really, integration testing is kind of at that highest level of dealing at the point and click sort of level, and then everything else is below that, right? Your routing, your views, your models, your database calls, et cetera. Testing is really an art. There's certain strategies you can do to make sure that your tests are of high quality, but understanding how to test code and how to write code that's testable is not an easy thing, and it's something you get better at over time. So, a few things I hope you'll see today is that testing leads to writing things to be testable. It helps to force your code to be modular, right? If you are trying to write unit tests and test certain components in isolation, those really have to be isolated, right? You can't have them tightly coupled or have things like, state that that make it difficult to test. So it forces better coding quality. So another way I think about it, especially if you're writing things like libraries or plugins, is that testing is almost the equivalent of UX, doing UX but for code. You're understanding how to use your library as if you were a user, right? As if you were someone integrating that library. Taking, what do I have to call to set it up? Can I make sure that I can, reset it easily? Can I do all the options work, et cetera? So writing tests forces better code. So let's actually get into some nitty-gritty. So true test-driven development means that you write the code, write the tests before you actually implement the functionality. So that test should fail. If I say, my shifter when I turn it should go from 6th to 7th gear, and I don't have a shifter, it should break, right? Same thing with code, absolutely. Yeah, that cycle of writing the tests first, them failing, is called the red-green cycle. So you write a test, it's red, meaning it fails to start, and then you try and make that test pass. The third step, get you in a second. The third step is refactoring. So once you have tests that pass, you improve your code and try and not break the tests. So there are many, one thing that comes up a lot when you say like, oh, you should start unit testing. It's like, well, I don't know what framework to pick. They're all exactly the same. Don't let anyone tell you otherwise. There are nuances of like, this one does this thing slightly differently. This one supports, has support in these sort of build tools. those are very, very small differences in the grand scheme of things. The general, what they do is allow you to describe certain pieces of functionality and then test that certain things are true. That's all. So let's go with a very simple function. Okay. Is that font size okay from the back? All right. So let's say we have a count and a function to increment it. Pretty simple, right? If I ask for the count variable down here, what should the value be? 0, right? I haven't called increment yet. So I get 0. Okay, so prints out 0 on the right. So if I now call increment, what should count be? This is manual testing, right? This is saying, what should my initial state be, right? The test, how would you, the way you describe this initial test is, initial state should be 0, right? Then I'm testing that calling increment should make the count 1, right? These are tests. What's not so awesome about this is that it requires me to manually type this in the console, right? So wouldn't it be great if we could have this automatically kind of report for us, right? So you can imagine up at the top, this section in here, the section here is like my app code, right? So that's something that you have in your JavaScript files for your application. Then separately, I would have the tests. So this isn't something that I would want to give to the user of my application, but I want a way to run them. So this is what a test framework does. It loads your code from your application and then separately loads code to run it and then check that certain things are true. So what I might say here is, if the count is 0, then my initial state is 0. And that would be the success case, right? So that's a pass. If it's not 0, then it's a failure. So the initial state is something else. So if I run this, I should get that pass initial state is 0. If I'm going through and modifying my code and I accidentally type something there, what's going to happen? It's going to fail, right? I have this code that automatically when run, automatically checks if my code is correct or not, right? This is really nice. Now I can be sure that no matter what happens to my code up at the top, I can verify that this function is going to continue to work. This is a very simple example, but you can imagine in a larger application that like saving, when the user types in their profile information or their full name, it gets saved to that database and displays when the page refreshes. Right? That's really, really powerful. So so this would be my first test. My second test, maybe I want to do some test-driven development here. I want to have a reset function. So I would call reset. Let's say I'd increment first. And reset, and the count should again be 0. So the pass case, right, the success case is that it actually went back to 0. The fail is that it didn't reset. So if I run this code, I get an error, right? I didn't have to actually do anything in terms of going and like clicking and figuring out why a button isn't working or something like that. I have code that's doing it for me, right? Code testing code. So this is, at the top we have a test that's in the green state. Under that we have a test that's in the red state, right? It gave us an error. So now we've done the red step of test-driven development. Next is green, right? Try and get it to work. So I then write a function that sets counter to 0. So when I run this, now it works, right? I have now completed one cycle of red, green. I'm sorry? Oh, did I screw that up? What did I do? Count. Yeah, there we go. Thank you. Okay, so yeah, so that actually, it happens to be green, but if I had a real test framework, it would have said fail. Or I'm sorry, it would have displayed as red. It just happens to all be console here. So there I have a different failure in that my code was not correct. Right? So that was, I didn't mean to make that mistake, but it was good that I did. Right? Proved the point. So now we still have this failure case, but if I correct that, both should now pass. Right? So now I've completed that full cycle. If I had code up there that I wanted to make better, now that I have tests that ensure that it works, I could make my, clean up my reset function and make sure that it's as clean as I want it to be and ensure that it still has the same functionality. So these are some really nice things about automated tests, right? It protects us from ourselves. So what if I change the behavior a bit and I said, okay, the count is going to start at 6. When I run the test, what are they going to say? So the first one will fail because the initial state was not what we expected it to be, but the second one still passed because we reset. So with automated tests, you want to be aware of any state in your application, right? Here, I'll get you in a sec, Pedro. Any state in the application can lead to weird things about our tests, where the first test is dependent on the second one, or it can be, right? Because we have this global counter or count variable. So one thing you want to do is make sure, which makes testing a lot easier, is to make sure that you reset state before every test. So before every test, I would say reset. And now when I run it, they both pass. So at the beginning of any test, I'd want to reset the state, whatever that means for my application, right? That might be clearing the database. That might mean any clearing out local storage, whatever it is. We'll want to know that every test starts from the same place. Has anyone seen this game before or something like it? There's like an iPhone app called Click the Cow or something like that. It's this goofy thing where all you do is you click a box and you get points for it. That's all it does. So we have a box that's clickable. We have the score being displayed down at the bottom. So what we want to do is test and make sure that this thing works, right? So just to walk you through the code a little bit, we have so this is in Backbone. So I have a box view that has that gets clicked and updates the count attribute of the model. So there's a model that stores the score, right? So it's a score model with a count attribute. So when we start off, we want the score to be 0. And we have a box that knows about this model, which increments the score whenever it's clicked. Then we have the score view, score model, whatever. And then within there, we can describe certain pieces, certain aspects of the functionality. So, updates the score model. I didn't write that very well. It updates the score model when clicked. Right? So these names are just meant to be helpful to you and other people on your team, other people using your code, of understanding what they're supposed to be doing. So what would I do? How would I set this up? Instantiate one, right? Get an instance of that model to test. Generally you wouldn't have, with tests, on this page, they're both running simultaneously. Let's say we commented out the init. So it's not actually going to start the application, but we have all the models and everything defined. This is how your test would normally work. It wouldn't, load the home page of your app, but you would load all of your JavaScript code or all of your, whatever app code. So we can copy this exact same line, right? So this test will have its own score model. Okay, what do we need to do next? Yeah, so what we really want to test here is the view. The view happens to require the model. So we've gotten a score model instance, but we need to get a view instance. So we can load that from there. So now we have a model and a view. What do I do now? Say it louder. So yeah, we want to click on the view. How would we do that? Okay. So there are a couple ways to do this, actually. So the score view has a clicked method on it. So we could just call that directly. And this is where you get into that sort of gray area of like levels of testing. Are we testing that method, or are we testing the fact that when it gets clicked, it does something, right? Because those are two subtly different things. I could test that method, but then what if I delete this, right? It's not actually testing that full end-to-end, which might be fine. You might have tests at both of those levels, depending on sort of the complexity of it. But know that the more focused your test, the less coverage you have, right? It's not actually then checking the event handler, it's just checking the function itself. So something to be aware of. So yes, absolutely, we could call score view dot clicked. Okay, and now in English, what do I want to put? Yeah.
I have a question on that line.
Yeah.
What if you didn't know that there was a click method?
That's a great question. We'll get back to that in a second. So what do I have to do now in English? Yeah, check the score. So there are, every testing framework is going to have its own way of doing what are called asserts, basically ways of doing checks. The if statements that we had in our sort of homegrown tests before of if this thing is true, print out that it passed. If not, then fail. So there are a lot of libraries like this, and they vary based on what test framework you're using. I'm using one called expect.js, but there are a million. So the syntax is that you say expect, and then whatever value that you retrieve, whatever value you want to check. So I would say, what is the thing I want to check in here? The score model. Okay, what specifically? So score model. Yeah, so I want to retrieve the actual value of that attribute, right? So within here, the thing I'm checking is score model.get count. Okay, so what do I basically want this line to say? Yeah, that should equal some value. In expect.js, that syntax is .to .equal, then what should it be? 1. So you have your, what's called the actual value on the left, expect the actual to equal the expected. So the value on the right is what we want it to be. So if I run Mocha and I get my output, so what happened here? Score, what did I do?
Click design box if you not see it.
Thank you. So this is a case where it's red because my test is wrong, right? That happens sometimes when you're writing the test. So I'd have to correct this by, when you see an error like this, you have to, you have to go and look at your test first. If the test hasn't yet passed, that doesn't guarantee that your test is right. So the first place I'd look is the test, which someone did for me, so thank you for that. So instead of the score view, I'm going to use the box view. And it passed. If I remove some code, right? Let's say I accidentally remove it, or I'm doing something else and I refactor. It's going to give me an error saying, sorry, this test failed. I expected 0 to sort of equal 1. So sort of, it means there with deep checking of objects and things. Basically what it's saying is the value that you thought you should get is not what it actually returned. So because our test passed before, we then go look at our code and figure out what actually went wrong. How do we get our tests back to working? Okay, so this is the basics of writing a test. When you have something like, a framework like Backbone. So what might another test be for this application? Sure, yeah. So not only when clicked is called, but yeah, maybe we want to check that the event handler actually works. Sure, so what would we do? Yeah. So what we can do is say, and let me go and break my application. So I'm going to comment out this part, right, of not actually having the event handler. This test doesn't check that, right? As far as the tests are concerned, my app works. So there's an aspect of testing of knowing how much coverage you have, how much of your application is actually being tested. So, yeah, similar to this test, I'm going to say when it's actually clicked. So what we do here, instead of calling the clicked method, we'd call render. And then what would I do down here? This maybe takes a little familiarity with Backbone to know how to do. So yeah, we retrieve the actual element. So box.$L, and then we can call jQuery provides a click method on it. So we now render the box, so it actually gives us an actual element. We can fire the click event, right? And it should have the same results. If I output my code though, or if I output the results, it fails. So I would go in and check, okay, is my test doing the right thing? It seems like it is. Oh, the problem is that I didn't actually set up the event handler. Right, so I need to go back and do that. When I do, my tests pass and I know I got it working. So yeah, there's testing at different levels. This happens to be a very small difference, but it could be, when I log in, does it, or when I create an account, does it, set my account balance to 0? It could be at that level, but it could also be, when clicked, does this thing turn green? Like I mentioned, there are a lot of test frameworks. I happen to like Mocha, but it really doesn't matter. I have a blog post linked from there if you're interested in reading more about that's a comparison between Mocha, Jasmine, and QUnit, I think. So you can check that out later if you're interested. Okay, so I'm going to stop talking really soon, I promise. So in an application, there are a bunch of ways to set up tests. It's going to depend on the framework. You can do fancy things like having part of your build script run the tests. So anytime I make a change to my file, the tests get run. You can set it up that way. For this application, for this demo, we are going to make a very simple, the simplest way to add the test, which is just a static HTML file. So this test setup links to the actual pull request in which I added the tests. Some changes to the README. So Mocha, you install with npm, Node.js's package manager. So I install Mocha and expect.js. Then create an HTML file, which is just the boilerplate off of the Mocha website. It loads in a style sheet for Mocha. It creates a div with ID Mocha, loads the Mocha JavaScript file, and then the expect.js JavaScript file. So with Mocha, it doesn't come with a built-in assertion library, right? A way of doing checking. Other frameworks will come with their own, but Mocha doesn't. So the thing that actually does the checking, we load separately, and then just some boilerplate here to do setup. And we load our code. So if you haven't already, clone this application, which is linked from the top of here. So the sample app. So do that. There's instructions in the README. So clone or download it, npm install to install the packages, and then open this index.html file, or under the test. So open the test index.html. So you should get, okay. So you should see if you installed everything properly, you should see something like this. So this is just like what we saw before of having our test output rendered. So for testing, when you're doing through an HTML page like this, you're going to make a separate page that runs your tests. So this isn't the application, but it loads all the JavaScript files from the application. So yep, just what we saw. And it loads my tests as under example.js. So example.js is very, very simple. It's just testing something built in about arrays. I can nest, with Mocha, you can nest your sort of groupings. So describe the class, describe the method, and then describe the functionality of it should do something. Okay, so same format here. Expect the expected value to be, expect the actual value to be the expected value, right? Very simple. So what you'll notice is that I also have in this test file, I also have all of the scripts loading from the application itself. So like the bundle, backbone, all the plugins, etc. So what I'm going to do is include a meeting.js, which is all my tests for my meeting module, so my model. So in there, I'm going to say that entities.meeting get and set. After I set some value, getting should return that new thing.